Welcome to qnawire.
Hi, so over here we're going to have the following Diels-Alder reactions with some heteroatoms thrown in our way. So remember that for Diels-Alder, the nice thing is that it doesn't matter the structure of the DNA file, meaning that it may have heteroatoms. The pattern stays the same. And this is going to be true always. So as long as we have the proper labeling, I'm going to use it in red over here, of our DN and the DNA file, 5 and 6, we're going to have no issues whatsoever. Remember that the reaction is going to go, a pair of electrons from the double bond is going to generate a bond towards carbon 1. This pair generates a pi bond in between 2 and 3. And the other pair is going to generate a bond in between carbon 4 and 5, and part 5. So in general, what is going to occur is that the bonds that are being formed are going to be in between, let's label this, let's label atom, well, carbon 1, yeah. Let's use carbon 1 and atom on the 6th position, a pi bond in between carbon 2 and carbon 3. We're going to have also a bond in between carbon 4 and the atom on the position 5. It may be a nitrogen, a carbon, any other heteroatom. As long as it satisfies the condition that this is going to be a DNA file, things are going to work through. And the ones that are being broken are going to be a pi bond in between carbon 1 and carbon 2, the pi bond in between carbon 3 and carbon 4, and the pi bond in between the atom at position 5 and the atom at position 6. So this is going to be the pattern always. It doesn't matter what is going on with the structure of the DNA file. So for the first reaction, the product would be the following. We have CH3 over here. Also, I always recommend you to write it down as a cyclohexane over here, and then use the labeling position to substitute everything that you need. So for example, in this case, in positions 5 and 6, we should have nitrogen atoms. So let's add them here, nitrogen and nitrogen. We had initially a double bond, which is going to be broken. So now we're going to get a single bond in between these two guys. And then we just need to complete the structure with whatever we have left. Remember to include the double bond in between carbons 2 and 3, and connect whatever was on carbon 6. So in this case, we would have the following group, OC2H5, and down below the following, OC2H5. And this would be our product for the Diels-Alder reaction on the first case. For the second case, we're going to follow the same pattern. Let's do the labeling, 1, 2, 3, and 4, and 5 and 6. So what is going to occur, again, from 6 to 1, well, actually from the double bond to 1, sorry about that, the pair of electrons of the double bond towards this position, and the pair of electrons going into carbon 5, well, in this case, atom 5, right? So we're going to begin with writing down our cyclohexane. In position 5, we're going to have a nitrogen. In between 2 and 3, we're going to have a double bond. And next, just complete the structure. The nitrogen is going to be connected to this group over here. Double bond oxygen, OC2H5. And with that, it would be all. Thank you very much, and have a good one.